All right, Peter. So you were asking about more R&D tests, right? Or not R&D tests.
No, standard tests.
Standard tests. So that's more of our efficiency map. And here we're going to have an example of efficiency map where we're at a speed, we're going through a variety of torques, and we can look on the left-hand side over here, and this is my previously recorded data, and these are all trigger points. So every time you see a T, that's a trigger point, where we're just taking a little bit of data at a point of interest. And I'll zoom in around this. So we're just taking a little bit of data at all these points of interest, and let's auto scale those so it looks reasonable. So we can look at our test, look at how it's progressing, look at our switching, look at our currents, and see that live. So we have a scope view and we have a previous recorded view. So here in the more production optimization test, you kind of know what you're looking for. So you only need data at those specific points.
Got it. Okay.
But what we're really after is these efficiency maps.
Yeah.
And we've got our torque, we've got our speed, we've got our drive efficiency, and then we've got our efficiency maps, which is pretty cool because we've got this Excel type data where the people who just want to look at the top line numbers have their Excel data. They've got their maps and they've got an intuition for here's my efficient spot, here's my inefficient spot, or flip that.
Yeah.
But then you've also got that data. So if something goes wrong, or there's something you don't expect, you have data points from each and every measured point.
Okay.
So now when our motor and inverter are working together, we're out of that R&D phase, and now we're just looking for anomalies at the points of interest. We're looking to optimize that vehicle level control.
Got it.
And so this is like an awesome tool, because now you have all the data if you need it.
Yeah.
You've got that Excel sheet if you need it, and you've got your map already printed out for you. And then the test finishes, each one of these triggers, and I think one of the other real important points of interest, if we're talking about what HBK can do to help customers, is how fast we can test. If we zoom in on one of these points, we've got really good data in just a couple of rotations of the machine. We've got really good data, really good measurements in just a couple of rotations. I can go to my power and, I'll stop our recording. I can go to my power and I can look at a point.
These are all the points, right?
These are all of those trigger points. Okay. And I see a super stable power measurement, super stable RMS, and if we look, it's 50 seconds per division, or 50 milliseconds per division.
Okay.
Each one of these points is 0.1 seconds.
Okay.
Because of the cycle tick, add a point, measuring, add a point, measuring, add a point, measuring. So you can move through this so
10
quickly.
10 times a second.
Yeah, 10 times a second. And you have to transition between points. You have to let the machine cool down.
Okay.
But look, if our machine can move faster, we can test faster. And you can save a ton of time, a ton of effort.
Is that back to that 2 days that we talked about earlier?
That's back to cutting that 2 weeks down to 2 days.
Fantastic.
Yeah, so it's really cool stuff we can offer, and this is this just saves you time, right?
Yeah.
It saves you post-process effort. It saves you energy.
You're just gonna send this back to the design team, test done, or
yeah.
Report,
Hey,
here's what you cut and paste this in. Yeah.
Boom, off to the races.
Neat.
Yeah.
That's nice and easy. We made that easy for them to export this information.
I think we made it pretty easy. We always like feedback from the customers, and then
That's great.
You've got everything in one place.
Yeah.
You've got your recorded data from a scope. You've got your really accurate power measurements, and then we have the added stuff like the Excel export, like the efficiency mapping.
And what would tell you when you're doing all these more standard tests, as in just not an R&D test kind of thing where you're interacting constantly. But what would tell you if it wasn't working right? What would tell you if maybe you didn't have a sensor in the right place? Maybe the rig was unstable or whatever. How would you know that?
Yeah. How would you know something's not going right in the test? You've got your expected values, and I think that's an area that we're also looking into is how do we give you that intuition?
Yeah.
Because right now, I've got the background in motors. I can look at my signals and say, yeah, all right, these three-phase voltages and currents, these look right.
Yeah.
I've got that gut feeling, but a lot of people in the industry are coming from a mechanical background. They don't necessarily have that.
No.
So, we have experts on our side who can help you look at your data. You can send us a data file and say, Mr. Supplier, this isn't working right. And we can help you work through that for people who maybe don't have the experience. But we are looking towards how do we automate some of this intelligence.
and we build some of that into this so that it'll say, that's
Yeah.
you know,
Hey man, you should probably check out your cabling.
Yeah, or even like, I mean, a torque sensor might not be fitted correctly.
Oh
or
yeah,
something. Cool.
yeah, absolutely.
Yeah, cool. That's really interesting. Thanks very much.
Yeah.
Appreciate that, mate.
Thank you, Peter.
By the way, nice shirt.
I was about to say the same. Yours is a little faded. You've worn yours a couple more times.
There you go, there you go.